Oh, hello, hello. So let's go ahead and talk about section 3.4. All right, so section 3.4 is all about comparing measures of center. So this is really going to focus in on, should we look at the mean and standard deviation, or should we look at the median and the interquartile range? So again, remember in the previous lesson that from section 3.3 that we talked about how when data is skewed, it's better to use the median and interquartile range. And when data was symmetric, it's a lot better to use the mean and the standard deviation. Okay, so we're just going to kind of highlight that and talk a little bit more about, what are some things that are going on. Now in 3.4 right here, basically this talk that we're having right now is all the information you need to know, and you just apply this information into a few questions that are happening on your assignment. There's not a lot of application to this other than, which one is better to use. And again, we're going to talk about that. So mean versus median. So as we said, when it comes to symmetric distributions, we usually go with the mean, but it's important to know that in symmetric distributions, the mean and the median are approximately the same, because in symmetric distributions, the mean, median, and mode are all in the middle of the data. And I'm going to show you a picture of that here in a second. But when it comes to symmetric distributions, the mean and the median are pretty much the same. Okay, so you could actually talk about with symmetric distributions either one, but the mean is usually the better to talk about in symmetric distributions. Where when we were talking about right skewed and left skewed, the median is the better one to talk about. But just kind of relating it back to the mean, in these kind of distributions, the skewed ones, the mean is greater than the median in a right skewed distribution. Okay? In a left skewed distribution, the mean is less than the median. And we're going to talk about why this is happening in this section specifically. Okay? Why is the mean bigger than the median here? Why is the mean less than the median here? And we're going to talk about why that's occurring. And it's better to use the median because of what is happening to the mean. Okay, that's why the median is a better choice in skewed distributions. And we're going to talk about that here in just a moment. Okay, it's because what is happening to the mean makes it really not the most reliable. All right. So right here, as I said, I wanted to show you pictures. So you can see the mode is in blue, the median is in green, the mean is in red. So you can see that right skewed where here's the median in green, and you can see that the mean is definitely greater than that median. Okay. Notice the median also typically falls around where most of the data is. This is why the median is a better choice. It typically shows what is happening around the mode. Okay. Where over here you see the left skew. Okay, you can see that that mean is definitely less than the median, which is right here in green. And again, the median is the better choice because the median is right here where typically this is everything that's happening. Okay. All right. And then down here, you can see when there's no skew, in other words, when it's symmetric, that really all three colors are right here. That's why it looks kind of black, because you got all three colors on top of each other, the mean, the median, and the mode. This is why I said a moment ago that the mean and the median are basically the same in a symmetric distribution. So you could actually talk about both. But usually in a symmetric distribution, we want to talk about the mean. Okay. So let's talk about what's going on with the mean. Okay. And that's because of outliers. The reason why we like the median in skewed distribution is because the median is resistant to outliers. Okay, that's what makes this stuff skewed so much. Over here, there's a data observation that we would think is an outlier, and the same thing down here. And this observation is pulling the mean, which would normally be in the middle, higher than what it normally is, okay? Because of this observation out here that is extremely large. And the same thing down here. We got an observation that is extremely low, and that's pulling the mean, which would usually be in the middle, down here towards the lower side. So the mean is greatly affected by outliers, okay? So that's why we don't really like the mean when we talk about skewed distributions, because the mean is being affected by this weird, unusual data result that we have, okay? So please know, remember I talked about outliers earlier, that outliers, they could be mistakes, but they also could be something that is extremely unusual and interesting about your data. So we don't really just discard outliers right away, okay? We want to talk about those. We want to learn from our outliers. But what I said a moment ago is your median is resistant to those. Just because you have a huge number out here, that doesn't move the median at all. Because remember, the median is the middle of our data. Okay, we're counting from the outsides all the way into the middle of our observations once they are in order from least to greatest. So just because you have some huge number out here doesn't affect the mean. Okay, it does, or sorry, the median. It doesn't pull it one direction or another because the median is in the middle. The reason it affects the mean so much is because remember, the mean is adding all of our data and data results and then dividing by the total. So when you add in something extremely large or something extremely small, that, you know, that messes with that total that you're going to be dividing. The median doesn't have that problem. It's just what's the middle value of your observations. Okay? There's no adding or subtracting or anything going on with that. It's just what's the middle. That's why it is resistant. Oops, wrong side. Resistant to outliers. Okay, so again, it's important to know because it's resistant, what I was just saying. The median will not change even if a particular outlier is replaced by an even more extreme value. So say we were right in here and we have an outlier at 1,000. My median will stay the same if I exchange that outlier at 1,000 for an outlier at 1,000,000. The median's still the same. It didn't change it. Now, the mean would be affected. The mean would actually increase by changing it to a higher value. Okay? And the same thing for a lower value. If I have a value here at 100, my median here will not change if I took that value out and replaced it with 0. Okay? My median's still there. Now, the mean will change, and it will get smaller because I have a new 0 value. Okay, so there's a nice little illustration of how the median is resistant. Okay, all right. So the next one is when you compare, because what we want to do is we want to be able to compare data. Okay, so when we compare data, we always want to make sure that we are comparing the same measure of the center and spread. So that means if I have a data set that is symmetric and a data set that is skewed. Now, what we've talked about is in symmetric data, we want to talk about the mean and the standard deviation. But in a skewed data, as I said right down here in the note, we want to talk about medians and interquartile range. Now, you can't compare those. That's not apples to apples. That's apples to bananas. Okay? Mean and medians don't compare to each other. Standard deviation and interquartile range don't compare to each other. So when you compare distributions, you have to make sure that you're comparing apples to apples. Okay? So that means that if both datas are symmetric, then go ahead and use the mean. If both datas are skewed, go ahead and use the median. But when it comes to a symmetric and a skewed comparison, you need to use the medians, okay? Because the only way that we can truly talk about skewed data is with medians and interquartile ranges. And remember, as I told you earlier, this is that important piece right here. When it's symmetric, it's okay to use the median because the mean and the median are roughly the same. So when you have two different distributions, symmetric and skew, the median and the interquartile range are going to win out on that. Okay? Because you have to compare apples to apples. All right? I want to check something else. Yeah, we're basically at the end. So 3.4 covers questions 34 through 40. But before we get to that, I just want to make a quick note. In your book, they do talk about modes. The big thing about modes is mostly we don't really use the modes to compare because sometimes your distributions are multimodal and you want to break them apart. Sometimes you'll want to keep those together. And for modes, it becomes difficult to talk about modes when in comparisons. Okay. Basically, what the book says is when you're dealing with modes, if you want to compare, the idea is, does your summary make sense? Okay, that's the question they ask. Does it make sense to compare these modes or not? Because again, remember, some data has more than one mode. So is it better to separate that data and look at it, or is it better to keep it together? That's the tough call. So I just wanted to give you my 2 cents on modes. We mainly deal with medians and means. Okay, it's a little tougher to deal with modes because it's a little bit more there's a little bit more subjectiveness to it and things like that. They say it's a little bit more complicated. So kind of give you a heads up on that. So going back. So again, your questions for 3.4 are numbers 34 through 40. Thanks for stopping by.